Okay, so now we're in MATLAB, and we'll now walk through some of the ways that we like, or I'll say I like to do some initial exploratory analysis to make sure I understand the data that I'm working with. So if you saved the data from the website, you likely have a zip file in some directory if you are on a PC, or you have just a folder called all subjects if you're on a Mac. If you're on a PC, you want to unzip this file. So let's see if we can do this in MATLAB. So yeah, if you right click on the file and extract, I've already have the file here, but it should give you the option to create a new folder that is the extracted data. Okay. So just so that everyone can see that, I'm going to delete this file, right click here, extract, and now I see that it creates this all subjects folder within my current directory. So if you are new to using MATLAB, there are a couple of things you want to check at this point. So first, you can see when I opened MATLAB, I was already in the directory where this file was located, but that may not be the case for you. So when you save your data, regardless of whether you're saving it from you're downloading it online or you've pulled it from another computer, you want to be very thoughtful as to where you place that data in your hard drive. So ideally, you'll place this file in some folder on your computer related to the Repro Rehab course. Then what you want to do when you open MATLAB is select this button. So if you hover over it, it says Browse for Folder, and we're going to move into the folder where those data are stored. So if I click this, I see that my All Subjects folder is here. And I don't want to select this folder at this point. I just want to select the folder. In this case, I'm calling this folder Data, and this is the folder that stores my All Subjects folder. Okay? So I'm going to select this, and this is where we are. So now what I'll do is move into the folder where my data are stored. So here I'll just double click this, and what I can see now is that I have several different files associated with the data. So now we want to think about some standards that we might want to put in place to help us process our data. So one of the things that we talked about in previous videos is thinking carefully about how you name your files when you're saving data. And so you can see here that MATLAB is trying to organize these files by name. And in this case, well, this actually works well in MATLAB, but one of the things that we see is that our file names are not all the same length. Okay? So MATLAB recognizes that 1 through 9 come before 10, but that's not always the case with all programs and operating systems. So one of the things we're going to do here is just a manual correction to change the names of our participants. So for every participant 1 through 9, we're just going to add another digit to the file name so that all of our file names are the same length. So it's 4, 5, 6, almost there, 7, 8, and 9. Okay. So now we can see all of our file names are the same length, and that's going to help us automatically load these files into MATLAB. Okay, so now we have these MAT files. These files are, again, located within a folder called All Subjects that's stored somewhere on my hard drive. However, these files are not, just because I can see them in the MATLAB interface, it doesn't mean that they're available, the data inside those files are available for me to use in my code. The first thing I need to do now is to load an example file into my workspace so that I can now get a sense of what's included in the files. So just we're going to do what we'll refer to as a quick and dirty method here. I can click and hold one of these files, drag it into my command window, and you see that once I release the hold, this line of code appears. Okay? So this will be our first line of code in this tutorial, and this uses a function called load, and that function has one input or argument, and that's the name of the mat file I want to load. And you'll notice that the name of the file is surrounded by single quotes. Okay? And then that file name is passed into my function load by using parentheses around the file name. Okay? So one of the first things you want to be comfortable with is understanding what we call syntax. So syntax here is our file name, open parenthesis, name of our file, and then close the parenthesis. Okay. So how do we know that these data were loaded into MATLAB? Well, now we need to think about what we refer to as workspaces inside MATLAB. So your workspace has to do with or specifies the variables that are available to MATLAB or to you as an analyst. So currently, if I look to the right of my screen, this may be in a different place for you, but I have a window here called Workspace, and within that window I have a variable called S. Okay, so S is going to be the structure, as I mentioned earlier in the last video, that the structure is where my data are stored. So how do I see what's inside the structure? There's several ways to do this, which is generally true for most procedures in MATLAB. I could double click the workspace variable here, but what we want to get comfortable with is interacting with files, interacting with data via code. Okay. So also as a reminder, when I'm working with code in MATLAB, I can do so in two different ways. Either I can type code directly into the command window, which is what we're going to start doing first, or I could write that code in a separate text file within what we call the editor. Okay, so now let's explore our first structure. If you've never dealt with data structures in MATLAB, I have a link on the GitHub to some resources in the MATLAB Fundamentals online course that will help you understand what structures are and why they're useful. So for now, I'm just going to select S, press enter, and now I can see that my structure is made up of several fields. So one of the nice things about structures is that they create a compact way for me to store different types of information that are all related. Right? So instead of having 50 different variables in my workspace, I just have a single variable, and then I can access what I need by specifying fields within the structure. So just to begin, let's say I want to look at some of my EMG. Right? So when I want to access a field within a structure, I type the structure name, period, and then the name of the field. So because I didn't collect this data myself, I don't know exactly which EMGs I have and how I've organized them. So here we see that they have a variable called EMG var name. So intuitively, this is going to tell us the names of the EMGs, likely where they are placed. This variable is what's called an 8x22 character array. So here, the number 8, if we look at the manuscript, we know that corresponds to the number of signals that were recorded, the number of muscles that we have EMG for. And then 22 has to do with the number of characters or letters used to specify the name. So if I type s.emg var name, press enter, now I see which muscles I have. Okay? So I did something there that I will do throughout the course, which is what's referred to as a shortcut in MATLAB. But MATLAB has the ability to do what's called autocomplete. So if I do S and then dot, there I can access any of the fields here. But I don't have to type the name of the field fully. So if I just start by doing EMG and then pressing tab, what MATLAB will do is to say, okay, how many fields start with EMG? Let me pull up all those options, and then once the option that you want is highlighted, you can just press enter and it will autocomplete. Okay, so now I know which muscles are available in my EMG data set. But for now, what I want to do is plot the EMG for tibialis anterior. Okay, so I know that's the first muscle in this set. So now, where are my actual data stored? Well, when you use intuitive names in your data, it's very helpful for any end user, including yourself. So if I look through all of my fields, I see that I have some information about the EMG frequency, the side, the name, which we just looked at, and then there's just this field called data. So intuitively, I imagine that this is where my EMG data are stored. So I'm going to do s.data, press enter. And now I have a different set of information. So when dealing with data structures, one thing to recognize is that they are organized hierarchically. So you have fields, and then you can have fields within fields, and those fields can have different dimensions as well. So the data field within my main structure is now a 1x42 structure that has the following fields here. So if I scroll through here, I know that I'm interested in EMG. I may also want the timestamps for my EMG. So why does this say 1x42? Well, in this case, the 42 corresponds to the number of trials that were recorded for this participant. So let's say I want the EMG from the, and actually, let's see if we have this information. Let's say that I want the EMG from the 10th trial. So we're just going to start there. So I go s.data. Now I specify which element, in this case 10, of this array that I would like to access. Okay. So importantly, we do this here only because we have a 1x42 array in data. Okay. So this says give me the data for the 10th trial. If I just press enter, I see now that I have information, much more information about the 10th trial. So they're walking, I have some information about the duration of the trial, and then I have my raw marker EMG and ground reaction force data, as well as some data that were computed from those raw data. So again, I want the first EMG. So I can access that here. So if I s.data of 10 .emg. So if I press enter right now, this would just print to the command window all of the values in this this matrix. So just to gain some familiarity with terminology here, the field EMG is an 8x1086 matrix or an array. So most of the data that you will likely be dealing with are in some sort of a form of a numeric array. So if I want to access the first row of this data, in MATLAB I use parentheses and then specify first row and then use colon to give me all the columns. So if we stopped here and pressed enter, this would print out all the EMG values in the first row across all the columns for this trial. However, what I want to do is actually visualize this data. And so a quick and dirty way to do that is to create a figure and plot the data. So the command figure will open a new figure. I can separate commands here using a comma. And then if I type plot, open parenthesis, move to the end of the line, close the parenthesis, now I should be able to see this EMG data. Okay. So now we've created our first plot. So what do we have here? Well, when we think about any kind of figure, we want to think about what information is shown on the x and y axes. So in this case, the x-axis corresponds to the sample number. So again, I have 1,086 measurements, and so that's the maximum value I have here. And then the y-axis is the EMG amplitude. So we won't go into this into a lot of detail here, but one of the things to be aware of with EMG is that the signals you record on your computer or through your software are often amplified relative to their magnitude, measured at the surface of the skin. So you always want to make sure you understand the amplification factors. Sometimes that happens within the hardware or on the sensor, and then sometimes that happens within your software. Okay. So you should always be able to go back to what we call the raw voltage by keeping track of those amplification factors. All right, so one thing about this figure is that it's not very useful, right? It doesn't have much information, it just shows the signal. So what we're going to do next is do a couple of things to add some information to this figure. And if you are interested in learning more about just creating figures in MATLAB, there's another video that you can link, that's linked to in the GitHub, that really talks sort of all about making high quality figures and points to some tools that are particular to MATLAB. So the next thing that we'll do here is to start to edit this figure. Okay, so now that we have our first figure here, we want to start thinking about some things that we can change to make our figures more useful. The most important thing that we want to do here is make sure we add labels to our axes, and I'll show you all briefly how you can get an understanding of all of the properties of your figure that you're able to manipulate. So first we want to distinguish between a few different things. So in our figure, if I select the arrow button here, this will allow us to edit the plot. Okay. So the first thing is that I can click on excuse me, the data, so that the trace here. And this data trace has some of its own properties. And one of the ways that I can see that is as follows. So there's another function in MATLAB. So I think so far we've used load, we've used plot. This is another function which lets you get properties of certain objects. So if I now that I've selected the trace, I can press type GCO. That stands for get current object. Press enter. And what I see are a range of properties for the line that I have on my figure. Okay. So if this is new to you, it may be a little bit overwhelming because there are a lot of properties here. The key point here is that when you have a graphical object in MATLAB, there are lots of settings that you can change to really make the figure look whatever way you'd like, and to communicate information as clearly as possible. So for instance, I have my color specified as red, green, and blue values. So these all range from 0 to 1 in MATLAB. My line style, so this will be a solid line. And then things like marker sizes and so on. Okay. So if I wanted to, I could access and manipulate these properties. So as an example, let's say that I wanted to change the color. Okay. So currently the color is this mix of green and blue, and I maybe just want to make a nice bright red line. So to modify properties of your figure, we're going to make these changes in a way with using a syntax that's similar to what we used when we were dealing with our structures. So here we can go, actually what we're going to do now is we're going to modify our properties using the set function in MATLAB. So if we do set GCO, now we have a comma and we have another input or argument where we specify the name of the property. So we want to make sure that this name corresponds to what we have here. And then we need a value. So these are what are called name pair associations. So here, if I want something that is completely red, I set my red value to 1, my green and blue values to 0, close my parentheses, press enter. Okay, so now I should have a red line, and that's what I see here. Okay, so that's just one example of how we can change our line properties. You could also specify multiple properties at the same time by just, for instance, if I wanted to set the line width. So again, I can use autocomplete to type the first part of the name for a given property, scroll down to what I want to change, and set this to 2. Okay, so now I've changed the color and line width with a single line of code. Oh, sorry. So now we'll go through an example of me making mistakes. So now what happened here? Here my whole plot turned red, and that's because I was no longer selecting the line. I was selecting the whole axis here. Okay. So now we're actually going to do a little bit of debugging. So I don't actually know what that initial setting was for my plot. So let's see if we can figure this out together. Okay, so I'm going to try to get this property. Okay. So this should be for my axis. So our line width and our color. Okay. The first thing I'm going to try is to set the line width to 0. Okay, so there shouldn't really be lines on this figure. So that's not going to work. Let's see. Let's try setting our color to white. Okay. So white is going to be now the background color for our figure. The line width specifies the thickness of the line around my axes. So now I want to set that line width back to 1. And that looks more or less normal. Okay, so originally this line width, I believe, was 0.5. So now what we can see here is this, again, this idea that we can set multiple properties, and we can see what the current value of those properties are using the get function. So we started with our line trace. The next thing we were going to do was our axes, and we did that, in fact, by mistake here, but it works out well. So if we scroll up in our command window, remember when we last used the get function, we had our axis selected. And so now we can look at all the different properties of our axis. So some things you might want to do are, for instance, turn off the box on your axes. Sometimes the box doesn't really communicate information. You can also look at things like the font name and font size. Font size is something that you will almost always want to make larger to make your figures publication quality. And let's see other things. There's information about the legend and many other features associated with your plot. Okay. And then finally, so we've talked about setting properties of the line, setting properties of the axes. We can also set properties of the figure. Okay, so for this, I'm going to select the gray box here. I'm going to see what these settings are. So get current object. And now I have another set of properties. Okay. And let's see if we have, so some key properties here. If I look at my figure in MATLAB, when you create figures, they have default name and number, figure, and then whatever order number figure you have open. So this is called a number title. So you can see here in my properties that the number title is on and the number is set to 1. I can and then I have the name, right? So the name here is empty. So I might want to set the name of this to the TA EMG. Okay. So these are just some examples of how you can interactively work with figure properties in MATLAB. So now I'm going to use this command CLC that clears my command window. And now we just want to do a couple of things. We want to set the name of the x-axis, name of the y-axis, so that we know what we're looking at. So I could use my, directly select the axis and then specify the properties there. Or in this case, I'll do a simpler version where I'm just going to make my x label sample number, y label TA EMG. And typically you want units here, but we don't actually know the units of our EMG. Okay, so we're going to remove that for now. So once I press enter, I see now that I have my X and Y labels. Okay, so one of the next things that I might want to do, again, this is the sort of exploratory phase of our analysis, is I might want to look at either other trials for this same signal, TA EMG, or I might want to look at other signals altogether. So we'll do two things next. First, we're just going to show how you can plot data from multiple trials on a single figure. And then we will take a look at some of the ground reaction force data and then one of the processed signals. So if I'd like to make a plot that's on this same figure, and I don't want to erase the existing EMG, I need to turn on what's called the hold. So I'll do hold on. So now I need to, I can call my plot command again and plot data right on top of my red trace. So how do I do that? I could write that command from scratch, but I've already written something similar before. And one way I can access that is by either pressing up to get to previous commands, or if I remember the command that I use, I can just type the name and then MATLAB will search the history for that command. Okay, so I'm just going to press up and I see my command was here. Okay. So I just press tab to get that command in the command window. So at this point, I don't want to execute this exact command, right? I don't need to open a new figure, so I can delete this. I also don't want to plot the data from the 10th trial because I already have that on the figure. So I'll just change this value to 11. Okay. So EMG is still the first row, all columns, so I'm still plotting EMG from the same muscle. Okay, whoops. So if I press enter here, I'm not sure what happened there. Now this should work. So let's see. Okay, so now it's plotting my EMG for this 11th trial. MATLAB will automatically cycle through colors, and I see that this EMG is looks like it's maybe time shifted, right? I have a burst here instead of here, and the EMG from this trial is this sort of orange color. Okay. So as we start to develop our analysis pipeline, we will work through some ways to call up data consecutively from different trials, plot many trials together to help us identify outliers, and then think through subsequent steps of our analysis. Okay, so now we'll look at a couple of different variables beyond just our EMG. So again, we're going to be working with our structure S. Press tab, that gets us to our data. Press enter. Now again, we see our 42 trials. We'll stay with that 10th trial. And now we'll look at our ground reaction force data. Okay, so we press up. That gets us to data. We use our parentheses to get our 10th trial dot GRF for our ground reaction force. And in this case, I don't know what the units here will be. So I'm going to actually go back, press enter. So now I see that my S.data 10th trial, the ground reaction force is 9 rows and 540 values. Okay, so what are these 9 rows? To do that, again, in this data set, this is again really a case for using data structures. I can go back to the top level of my data set here, and I see I have a variable called grf var name. So if I do s.grf tab down to var name, press enter. Now I see what I have. So I have my ground reaction forces in X, Y, and Z, my center of pressure in X, Y, and Z, and then my moments or torque in X, Y, and Z. So in this case, I'm just going to plot the ground reaction force in the Z direction. So I'm going to recall a line of code that I've already used that started with figure. So I'm going to press up to go to that previous line of code. And I know that I'm going to use a similar format that I use for plotting my EMG, and basically replace this with, I believe it was GRF. And we wanted the 3rd row, which corresponds to Z. And let's see if this works for us. Okay, so now I have ground reaction force. Again, x-axis is the sample number, the y-axis is the ground reaction force. Okay, so hopefully you can start to see how to interact with data structures, how to specify the field of a structure that you want to access, and then if a given field, for instance, has separate, let me go back here. If a given field is an array, in other words, you have several different repeating subfields that you might have, for instance, if you have multiple trials. We've now shown how you can specify a given subfield, then again dive one layer deeper to access the variables of interest. And this is really, again, just a compact way to represent data when you use data structures. So now we are starting to get a sense of the data. We can now think a little bit more deeply about how we want to analyze these data. But before we do that, we're going to talk briefly about how to get other types of data into MATLAB. Specifically, we're going to work with an Excel file, which is basically a CSV, and we're going to show how you can import this type of file into MATLAB. Okay, so the next thing we wanted to do is to work through an example of how you can import other data types into MATLAB. Specifically, we're going to do an example where we import an Excel file into MATLAB, and this will also work for CSV files. So when we import those files into MATLAB, we're going to use another data type in MATLAB that's known as a table. So we'll talk a little bit about how tables work once we get our data into MATLAB. So the first step is that we need a data set. And so what we're going to do is to go back to the website that we use to download our EMG and kinematic data. You scroll all the way to the bottom of this page, you'll find our demographics and anthropometrics data set. So if I select this link, you'll see an example or a snapshot of part of the table, where, as you might expect with a table, each column corresponds to a different variable, each row a different observation, and then each cell is going to be the value for that particular variable and observation. So if I scroll down to the bottom of this page, you'll see that there's a link to download the original file. I did that. I'm going to save it in the same place where everything else that I'm using for this course is saved. So for me, that's my repro rehab folder. I have some lecture material, and this will go into data, all subjects. So I'm going to store my Excel file there. Okay. So now let's go back to MATLAB. So in MATLAB, I can now see my Excel file. And what I'm going to do is create a new variable based on that file. So to do that, I'm going to use a command called read table. So one of the things that you want to get comfortable with in MATLAB as you're starting to learn how different functions work is to use the help. So if I do help and then read table, what I see here, if I scroll to the top, so there are lots of details and different ways you can use this function. But at the very top is a description of the function. So it creates a table by reading data from a file. And then here is the sort of simplest syntax. And then here's an example for dealing with an Excel file. Okay. So in this case, I have T, which is just the variable name I use for my table. I highly recommend using something more descriptive than just a single character. That's equal to my function name, where the input to that function is the name of the Excel file that I'm importing. Okay, so let's try this. So I want to use the exact same, I want my variable name to be the same as my file name. So I'm going to go demo underscore and throw is equal to read table. Now I have the name, demo. If I, again, with my autocomplete, MATLAB knows that read table is going to look for a file name in my current folder. So if I just type the beginning of the file name, I'll see a list. And if the file name is selected, I press tab, and then it autocompletes. So now I'm going to close my parentheses, add a semicolon. So we haven't done this yet, but when you excuse me, declare a variable or create a new variable by setting it equal to something, this is also called variable assignment. When you do that, if you don't have a semicolon, it will just print out all the values of that variable. And I don't want to do that right now. So I'm going to press enter. So MATLAB's taking some time to read that data. And now I have a variable called demo and throw in my workspace, and I see the number of rows and columns that it has. Okay, before we look at the data, you'll notice that there was a warning that popped up. So this says that the column headers from the file were modified to make them valid identifiers before creating variable names for the table. Okay, so what does this all mean? So first, column headers. That's just the name of the variables that's specified in the first row or the header row in my Excel file. And it says they were modified so that they can become valid MATLAB identifiers. And generally what that means is doing things like removing blank spaces or spaces in general from your variable names or strange characters. Okay. So here's something that is useful to do when you need to sort of move back and forth between MATLAB and a file in a different program. So in this case, I want to get a sense of what variable names were changed. So to do so, I'm going to select my Excel file here, right-click, and I'm going to open it outside MATLAB. So MATLAB knows this is an Excel file, and it's going to say, hey, Excel, open this file for me. So what we can see here is that if I look at my header row, the name of my variables has that there are both spaces and parentheses in these file names. And so now we can see how MATLAB changes these. So if we go back to MATLAB, in this case, I'm going to double click this variable to open it. And what you'll note is that tables in MATLAB have the same structure as tables or spreadsheets in Excel. So I can double click here, and you can see here that the spaces and parentheses that were in my original variable names are now replaced with underscores. So in general, when you are setting up a file and you're using text to specify variable names or participant names, you want to make sure that you don't have spaces, parentheses, sort of dollar symbols, or other symbols that can be misinterpreted by a program like MATLAB. All right, so now I have my table inside MATLAB. So why are tables wonderful? Well, they're wonderful, in my opinion, because they allow you to store data of different types, right? I have characters, I have numeric data, and they're intuitive, right? Because most everyone is comfortable with Excel files, and so they have the same format. But one of the nice things now is that I can start referring to subsets of my data based on the name of the column, right? I no longer have to refer to it, as the third column. I want all the values. So let's take an example. So one useful feature that you'll often use in exploratory data analysis is using histograms. So histograms are great for exploring the distribution of different values in your data set. So this is a nice way to see if certain measures are normally distributed or skewed, or if you have outliers of some sort. So let's just say for now I want to do a histogram of the age of my participants. Okay. So I'm going to create a new figure. MATLAB has a function called histogram. And as a general rule of thumb, if there's some sort of standard process that you need to do some sort of standard analysis or a standard figure that you need to create, there's a good chance there's a built-in MATLAB function to do that. If you don't know what that function is, then just type the name of what you're trying to do or what you would like to create in the help sort of search bar here, and you'll see some options that are most closely related to your query. All right, so now I want to do a histogram. And just in general, when I program, if I know I need something that has parentheses, I will both open, so that's the first parentheses, and close the parentheses altogether. In some cases, this is done automatically depending on what programming language you're using. So again, I want to look at a histogram of age. So I know I need to refer to my table, demo anthro. And now I'm going to again use this dot indexing that has become pretty common. I'm going to press tab. So this gives me some options for things that I can do with my table. So most of the options that you see here correspond to names of variables. So I have from left to right in my table, code, gender, age in years, body height, and body mass. But I also have some properties of my table, and then other things related to the rows and variables. So here I want to use my age in years and create a histogram. Okay. So I believe this should work. And there we go. So I can see that my participants skewed toward the younger end of the age spectrum, though my range extended up to people who are 80 years old. So just like any other function in MATLAB, I can use histogram with differing numbers of inputs. I can change my bin width. I can specify the color, add labels to this figure, and so on. Okay, so just always whenever you make a figure, as we will describe in the other video about data visualization, you always want to make sure that you have full control over what you're visualizing from your data set. Okay, so now what we've done is we've taken an Excel file. Again, this would work the same way for a CSV file. We've imported it into MATLAB using read table. We open that new variable, so we specify the name of the variable when it's imported. And now we've explored that variable, just seeing that it has the same format as our Excel file. We then, because we now have a table with variable names, we know that we can access each of those variables using dot indexing. Okay, so we have the table name dot variable name. And we can use that for different types of analyses or as to pass as input to, for instance, pre-existing functions like histogram within MATLAB. Okay, so we'll stop there for now. So these are just all examples of exploratory analyses that you might do. And really, I think calling this analysis is a bit generous, but it's really a way that you should get an understanding of your data before you start doing your analysis sort of full steam. So in the next video, what we'll do is work through how we might plan our analysis, so how we might sketch out a data analysis pipeline.